bit of a delay.
It's alright. I try to figure out how to run the CI of RPM, and I was not successful.
Alright, so what are we doing here? We're taking some Python module or C extension module or some project with a C extension module called RPM, which I think I have checked out. And it's at RPM Software Management / RPM on GitHub. Okay. And we're trying to make it work better with Python.
Apparently, or make it work better for the use case of people who are unhappy with how it works now.
All right. So it does have some tests, and somehow it runs those tests.
Apparently, and there is there's some documentation that uses make, and
Make
there is this
OCI.
upstream configuration to that.
Okay. In tests, there should be a make tree dot OCI. What does this mean? It uses Podman to put the working directory under SRV, and then it runs some image. It runs RPM tests in it. What's image?
It should be Fedora 41 currently. Oh
Image
no.
is RPM. Okay, does that get created here somewhere? Podman build target base T image base. Podman build target full. Standalone native build, standalone build. Okay, this looks containerized enough to try out.
Okay.
Well, I guess if I'm on Fedora, I should probably trust RPM, right? I'm probably trusting this project already. So I go into tests and I run make tree OSI build first, and then do check. Okay. Pull something, installs a bunch of stuff.
It's fascinating. There is readme in the tests directory. There is documentation. It all says use make CI, make tests, make install, and it just doesn't work when you type those commands they tell you to use.
Oh, they have documentation?
Um,
Oh,
yeah.
read me.
Yes, there's
Make install.
make check, make shell, make CI. There's a lot of makes, but there's no make file in the project.
What? Oh,
There are CMake files, but they don't recognize it just like that. And I wasn't successful with figuring out how to make it work. But to be honest, I only had 15 minutes to try it, so.
well. Okay, did something. Now we run sudo syscontrol mmap run rnd bits. High entropy setting is
Not that I want to.
Let's not do that.
Okay. It sounds like there is a bit of a situation on your end. I don't know if you're aware of that, or maybe having headphones.
Yeah, I have headphones, so there's nothing I can do with that. So.
Okay.
This is what it is.
Okay, just to make you aware that that there is something happening. Probably, maybe you want to take a look.
And the tests run.
Yay!
So that was pretty fast, but I think it only ran the tests and didn't make the project, which means if I change something to make the tests fail, where do I change something? There's a Python directory and module.c. So let's say I disable module initialization and test again. Some stuff is skipped. Now that succeeded, so apparently I need to build. Which will do a full configure, looks like. And then test. There we go.
It's not bad.
Right, so your homework is to find some RPM developer and ask them how to get the fastest compile and test cycle you can, and how to limit the tests that run to just the Python ones, because we don't need anything but the Python tests. I don't know why JSON format failed. These are macro manipulation, module import, basic header manipulation. Yeah, module import failing, that's exactly what we'd want. Right. It takes a bit of time, but I think we can live with that. So what are we doing here? What's the problem to solve?
So the issue is that RPM module cannot be imported more than once. Someone added code that specifically disables that feature.
Ah, right, this one.
Yes, yes, yes. So we can only load one RPM module per process. And there are uses of RPM somewhere out there that rely on the opposite, on the possibility to load more than one RPM modules.
Mm-hmm.
So we've got to change things in that. And the things in that mean that we've got to get rid of any globally accessible variables, types, and stuff, and put it into the module state and access them through a module state rather than from the global namespace.
Right. And I think there is one more problem. Because, so when did this change appear? That appeared with a particular version of Python, right?
Can you say it again? Sorry, I didn't get it.
So this bug appeared with a particular version of Python, right?
It started to happen with Python 3.13 by the bug report and RPM 420.
Do you have a link to the book
Yes. Yes, yes, I have.
So there's one more thing.
I'm sharing it in the chat.
So this so with RPM 420 it stopped working, and with 419 it didn't. Let's see if they have a change log. No. How do we know?
I think rpm.org, the documentation link there. Yeah,
Okay.
have.
So RPM 420. That's the one that ported this to the stable IBM. Okay. So it's not just that. Not just the Python version. But still, it would be interesting to see if the bug happens on Python 3.12.
Do you suspect
RPM? Because I think there's one change that was done specifically in 3.13, and I don't know if I can find that. But explaining it will probably take some time.
if it's brilliant, then
So there are two ways to create extension modules: the single phase init and the multi-phase init. So the way you make a Python extension module is you create a shared library with this function in it, PyInit underscore and name of the module. and you can return one of two things. Either you create a module object and return that, or you create a module spec object and return that. And if you do the latter, then Python will use that to create a module object. And a module spec has a pointer to a function to initialize that module. So that would be this init module. Here, this. So this one uses the old single phase where it creates a module and returns it directly. And the chain, so one more thing to note is that the single phase init is the traditional way to do things, and it's full of really weird edge cases. For example, if you have multiple interpreters, which I believe is what ModWhiskey does by default, it will share the module's contents between all the interpreters, which isn't really right. And there was an issue found, I think it was in 3013, where I don't remember what it was exactly, but where I guess some of the modules using the single phase init were expecting to be imported in the main interpreter. The first one, that's kind of special. Maybe it was some of the modules, maybe it was the machinery around single phase init or so. So the change to Python was that the init function is always called in the main interpreter first, and if it returns a module, then that module is imported in the main interpreter. And if it returns the spec, then I think the interpreter doesn't, Python doesn't go on in the main interpreter and imports the module in the sub interpreter. Yeah, and that gives us the problem where if you do this, this will be called in the main interpreter when Python tries to import this. So the main interpreter will get the module, and then no other interpreter can get it. So even though the RPM module can the RPM module can be loaded once per process, but with that change in Python, it can only be loaded in the main interpreter and nothing else, because that it gets created there first. If we changed this to multi-phase init and keep this restriction, that might mean the module can be loaded in one interpreter, but it doesn't have to be the main one. Which, first of all, it could solve the bug for some users if they only need it in one interpreter. I don't know what software this is, but if it just needs the module in one interpreter, it'll solve their issue. And it's also something we will need for the full change. So maybe let's try that first.
Okay.
So how do we do this? Do I type or do you type?
Let's think. This is very new to me, all of it. So
course. You're
I
jumping
can
in the deep end.
I can type, but it will probably be full of mistakes and
Right.
weirdness.
So change this to multi-phase inits. Let's me make a branch. So we need to change PyNet RPM to return a module def object, and we already have one. This is the PyModule def RPM, which has like the name, documentation, size, blah blah blah, bunch of stuff. Where was so we will need to move this module initialized check to init module. So I'll do that. So this sets a global variable. Like so, there's init module. So this check moves in here. And then we say that this init module it'll go in the PyModule def somehow. And how will it be? Let's look at the documentation for PyModule def, because I can never remember that. So PyModule def has base, name, doc, size, methods, and slots, and then traverse and clear. And this has mReload because this field was supposed to hold some kind of reload function, and that was never implemented, so everybody set it to null, and then it was repurposed, so it's now slots. By the way, there's a better way to do this in C, which you might remember doing something like this.
Yeah.
But I don't know if RPM supports the necessary C standard.
Ah, that sounds like something they should declare. What kind of C standard is supported?
Well, that's used for internal documentation somewhere. Okay, homework for you. Ask some RPM developer.
Okay.
Which C standard do they support? Can you use designated initializers? Meantime, let's leave it like this. So there's slots, and that's an array of PyModule def slot. So we need a static PyModule def slot array named module slots, which will hold some slots, and it will end with a 0 entry. And each slot is a struct with two things, a slot number and a slot value. And the slot number we want is called PyModExec, sorry. PyModExec, which is a function that takes a module, fills it up, and returns 0 if it was successful. I don't know how you could tell from the documentation that it should return 0, but that's the convention, and this one, it looks like it returns 1. So I'm not actually sure. What this should return. Huh. Do we have better documentation in the new version? No. Then I should probably look somewhere. It returns -1 on failure and 0 on success. So we need to change all the returns here. But we can keep the function, so this will be it. Module takes a PyObject, returns an int. But all the returns need to be -1 on failure. That's this register enum. Oh, this doesn't handle errors. No good for it. Okay, that should be all of it. These things should probably handle errors because each Python API function can actually fail. So this if return should be added there as well, but that's not what we are here for. Okay, so now I add these slots to here. By the way, there's a new standard where this can be replaced by mslots is, and then you do the type in parentheses and the contents after that. You don't have to pull it off like this, but that's even newer than the designated initializers, so let's skip with the old. Now let's stick with the old way of doing things. Since this is a declaration and not a function, it needs a semicolon, which is the most annoying things in C. And since there's a bunch of comments here, maybe this could need a comment. No, that says methods, so hopefully it's methods. Alright, so that would be the module def. The PyModule create will now create the module, and I hope it will also call the exec function on it, so we don't need to do this. And we can also return the module def directly, but we need to initialize it first. So there's a PyModule def init, which you need to call on the module def. Gives you a PyObject that can be returned directly. Now this command here is for the check, so it needs to move to the check. Okay?
Yeah.
So what changed? We put init module in a slot. We don't call init module manually, but we return the module def directly. And we move the check and change all the return values to -1 and 0. Will that work? So there's two commands: make tree OCI build and make tree OCI check. Let's see.
So you said there's the old way is a single phase, and then there's the new way is multi-phase initialization of module, and the new one is the spec one.
Yeah, you return a definition that creates contains the two phases. So there are actually two phases to creating a module. There is creating the module object itself, and then initializing it. It's like dunder new and dunder init in Python. So that's the two phases. And the magic here is that if you don't specify a PyMod create, Python will do that for you. And the good thing about that is you can use exec on an already existing module. So one of the reasons we were adding this is to be able to use extension modules as the main module, which exists very early in Python initialization. So that could be just filled up. But we didn't get to add the full feature after that. Anyway, it has a bunch of other more subtle advantages too. Anyway, the failure. There's a failure. Right, because I don't know my C syntax. Of course. So the array specification is not part of the type, it needs to be after the variable name. Because in C, type definitions put something on the left and something on the right. As you know. And there's a return null from init module. What? Init module returning null. Oh, the check needs to return the correct failure code for this function. Anything else? Not yet. Built successfully. There we go.
Yes.
I think the diff will be essentially the same as before. So let me commit this. Link to the docs here. Multi-phase initialization. process. Okay, this is kind of subtle, to say the least. It would be nice to add a test for this.
Mm-hmm.
And I saw the RPM tests once, but I don't think I remember anything about them. So there's a bunch of tests. One is called rpmpython.at, and this is M4. What a perfectly great and modern way to define your tests.
I've never seen it. I can read on that.
I don't even have syntax highlighting for this. GNU M4, I think that's it. It doesn't help too much. So M4 is an ancient formatting language. It survives in auto tools, like configure tooling, and basically you define some macros, and this expands the macros and comes up with well, I guess a shell script, or well, any kind of document, but I think in this case it's a shell script which well runs a Python test. So we give it a piece of Python and it'll probably import Python and import RPM and run the test and check the output. Use myprint instead of print. Now writing a test for sub-interpreters.
I think I need a little bit more context on interpreter and sub-interpreters. Like,
right.
there can be only one main interpreter, but multiple sub-interpreters. And what happens if I
ideally all of them are kind of the same, but each. So to start an interpreter, you call a Python function, and you can only call a Python function from a running interpreter. So there's kind of a tree of interpreters, and the one at the top, that like the first one that started and the last one that's ended, that's called the main interpreter. Some things can only be done in the main interpreter. I personally consider every such case a bug that could be fixed eventually.
Mhm.
But sometimes you just need the main one for interesting reasons.
So when I type Python 3 in my terminal, what do I run?
Well, one
It's significant.
Python interpreter gets created for you,
Yeah.
and you run that, and you can create extra interpreters, but there's no public Python API for it. There's only a C API for it.
Mhm.
So there is a private Python API for it, so that it can be tested. Do we have test interpreters API? So this will import the underscore interpreters module and interpreter support. Well, this will somehow create interpreters for you and run Python code in them. Now let's see, if I do Python and import underscore RPM. No. Can import RPM, but not underscore RPM. What is this? Oh, it's RPM dot underscore RPM. That's the extension. Yeah, there it is. And now I somehow need to create a sub-interpreter which doesn't have public API. Let's look at the API that does it. I just create it like that.
Mhm.
What I can do then? This is a number. Nice. So this is interpreter with ID 1, and I can call run string. Execute the so ID and script. Execute the provided script string in the identified interpreter. Okay. So interpreters dot run string, this one, and I print hello world.
Syntax error.
Yeah, there's a syntax error in it. Nice. Okay, so that was run inside an interpreter, and if I do import RPM, so I do import sys and print sys.modules, and this ends with traceback.
No RPM here.
If I import sys here and get sys.modules, this ends with threading, subprocess selectors. Yeah, these are interpreter related things, but there's RPM in here. Okay, and now if I create another interpreter with ID 2, unsurprisingly, and do, well, I didn't have to create another one, right? I tried to import RPM. This is an internal function, but it gives us a message. Module RPM does not support loading in sub-interpreters. Where have we seen that message before?
That's not the one.
Oh. Right. Right. Yes. So one benefit of the multi-phase init is that that module will support being loaded in sub-interpreters. So there's actually a slot for that. There's PyMod create, PyMod exec. There's also PyMod multiple interpreters, which you set to one of these, and the default for single phase init is not supported, and the default for otherwise I think is interpreter supported. And if you support interpreters with their own GIL, you have to add this one as well.
If it's not specified, the import machinery defaults to not supported. So can we just switch it to supported and have everything?
This might be a documentation bug. Yes, we can switch it, but I don't think I can get an interactive console with this RPM. Let's see. Is there there's an add shell? Which might give me a shell. Let's try that.
Okay.
So let's check interactive false. So I don't think I want interactive, and I want shell. I wonder what Python this will give me.
Fedora 41, that means 313.
That's
should be.
It's new enough. Okay. ASAN runtime does not come first in an initial library list. You should either link runtime to your application or manually preload it with LD preload. Ooh. Okay. Thank you for telling me. Sure, ASAN runtime. Let's ask the internet. Disable the check. Okay. This is a container, so why not? Oh, magic!
Oh, okay.
I'll need to
Beautiful.
put that in some notes somewhere. Okay. Nope. Does not support loading in sub-interpreters. Okay, so maybe we need that slot. Where was the slot? PyMod multiple interpreters. And put in this. Now the problem is this was added in Python version 3.12.
Oh, that's very new.
So we do if Py version x is bigger than 03, 12 in hex, 10 is 1, 10 is A, 11 is B, 12 is C. So that's, C is the minor version, or the minor version, we don't care about the batch version or the release, right? So you can also find this in the documentation. There we go. Right, so there's the major, minor, micro version, then there's release level and serial. There's also a very nice macro like PyPack version where you just say PyPack version 3.12 and it gives you this giant number, which I added this month.
Okay.
That's definitely too new. So let's do this only if that happens, which means now I have to rebuild the whole thing, right? 5 minutes to go. I should have saved the commands, right? Nope, something's wrong. Added in version. Oh, it was added in 3.12, so this. Oh, that doesn't really matter. What? PyMod multiple interpreters supported is not there. Oh, maybe it's not part of the stable API. What is this madness? And now Okay, that's weird. I hope somebody didn't change it to make this unusable. Where it was added, and hopefully the Python here is big enough. Oh, damn it. It was only added to the limited API 3C. Which sucks. Okay, there's something wrong in Python, I think. Like this thing is not as usable as it should have been. So I wasn't that much involved when this was added in 3.12. And I think it reduced functionality because before the default was definitely PyMod multiplier supported. Okay, I guess I need to file a bug for Python. Or maybe think it through a bit more. Or maybe just put in the number. Right? It's part of the stable ABI. It's fine. Anyway, we're out of time. So you have your homework. Try to run the tests as fast as possible after a change. And I will think about this in the coming week.
Okay, I will try to familiarize myself with that, and I will try to figure out what C standard is used by RPM, whether it supports the nice DOS notation.
Right.
That's my homework. Okay.
All right. Thank you.
Thank you. It's insightful. So see you in 2 weeks.
Oh, in 2 weeks, right?
2 weeks, yes. Next week I'm in a train, so I can't, but in 2 weeks.